Okay, I just want to quickly give you a little bit of advice on how to solve 6 and 7, because I know there was a couple of people who struggled because they tried yesterday. So in 6, you've got two forces that you need to calculate the resultant force. And the two forces I've given you are not parallel to each other, they're not even perpendicular to each other. So you can only solve these problems when you make all the forces parallel and perpendicular to each other. If they're parallel to each other, you can just add or subtract them. If they're perpendicular, you can use Pythagoras' theorem to work out the resultant. So what we're going to do, we're going to take this 11 Newton force first. Sorry, I can't draw very well on top of the screen at the moment. And you're going to resolve this 11 Newton force into one, its vertical part, which will be like this, okay, and one, its horizontal part, okay. So you're going to get rid of the 11 and you're going to replace it with these two. Now, once you've replaced it with these two, you can see we've got two forces that are going to be horizontal. We've got this 13 Newton, and we've got whatever the horizontal part, the 11 Newton force is. Now, because they're acting in opposite directions, you're going to subtract them. And what you're going to find out is going to leave you a resultant horizontal force acting to the right. So you're going to have 13 minus whatever the other force is. Now, when it comes to the vertical direction, we've only got this one force, this vertical part of the 11. So we haven't got to do any adding or subtracting. We're basically going to be left with these two forces. And once you've got those two forces, you've now got two forces that are at right angles to each other. So you can work out the resultant, which is going to be kind of the hypotenuse of this triangle. Okay, but what I've got to remind you as well, not only do you need to find the size of it, you also need to give me an angle for the direction as well. Okay, so I don't think that's much different really from what we did in 5. 7 is very similar as well, but it's a bit more time consuming because here you've got three forces that are all acting at different angles. None of them are vertical and horizontal to begin with. So what you've got to do is break down each force into its vertical and horizontal components. Okay, so you're going to have to do 6 calculations here. So let's start off with the 14 Newton force. Okay, you need to break this down into its vertical part and its horizontal part. And then you're going to move on and you're going to do the same with the 16 Newton force. You need to know its vertical part and its horizontal part. And then you're going to do the same with the 8 Newton force. Yeah, you're going to do its vertical part and its horizontal part. And then once you've got that, you need to combine the 3 verticals and the 3 horizontals. So you've got 2 vertical up, the red up and the blue up. So you're going to add those two together, okay? And then you're going to subtract from it the vertical down, okay? And that's going to leave you with one vertical force. I think it's probably going to be in the upward direction, but we'll have to do the calculation to check. Now, in the horizontal, you've got this one red one to the left. Okay, well, you're going to subtract that from the blue and the green one. So you're going to add the blue and the green one together, and that's probably going to give you a resultant to the right in here. And then once you have that, you're going to combine them using Pythagoras' theorem again. You're going to get the resultant here. You've got to remember to give me the angle as well. Okay, so this bottom one's pretty time consuming because every time you resolve the force, you've got to do a sine or a cosine calculation. So you're going to do 14 cos 60, 14 sine 60. 16 cos 40, 16 sine 40. 8 cos 70, 8 sine 70. Now just be a bit careful about which one gives you the vertical and which one gives you the horizontal, because remember that they change the angle a bit. So the 60-degree angle is measured from the vertical, but this 40-degree angle is measured from the horizontal. So if in doubt, you put things into triangles. So for example, for the 16 Newton force, if I wasn't sure about this, I would have my 16 Newtons, I would draw a triangle like this, I'd make this my 40 degrees. Okay, so this is my 16 here. And I would know, well, if I want to find the vertical part here, well, that's looking for the opposite. So I would do the sine of this angle theta here. If I want the horizontal, then I want the adjacent. Okay, so I would use the cosine. So just if in doubt, turn them into a triangle and solve it that way. So I will check your answers, and if there's any problems, I'll share the mark scheme with you. Thank you.